average speed. Can class?
Can, teacher.
Okay, thank you. And number 3 over here. Okay, Savez competes in the 100 event, a meter event during the sports event in his school. The speed time graph shows the speed of Savez up to the finishing line. Calculate the value of t. Okay, so we have already what? We have already what, this one? The distance give already. Okay, the distance given already. Okay, so we are going to find the total distance over here is going to be equals to our what we call the total area under the graph here is going to be equals to 100. So we are going to make this one. So is it we can use trapezium also, this one? Is it? Is it given we can use trapezium? Can we use trapezium? Okay, I think I'm going to use triangle over here. And the other one I'm going to use trapezium. This one. So what I have over here, the first one is 1 over 2 times with, okay, I'm going to have over here, which is t minus 6, okay, and then times with 8, okay, plus with, okay, the other one we have over here is 1 over 2 times with the parallel line over here is, this is going to be our parallel line, which is 8 plus with 12, okay, and times with this one is we are going to get t minus 6, isn't it? t minus 6, t minus 6. Okay, sorry, this one should be in bracket also. T is going to be minus with t minus 6 over here. Okay, so you are going to get that one. Okay, I can simplify first this one. So 2 and 8. Okay, sorry. This one is going to be equals to 100 because we have already the distance. Okay, it's 100 meter. Okay, and we are going to get this one is 4. So this one we are going to have t minus t finish. This one negative negative. You are going to get positive 6 over here. So this one I'm going to get 3. Okay. So anything that I can simplify? None. Okay, so what I have left here is t minus 6 times 4. Okay, that one. Plus, okay, this one 8 plus 12, you are going to get 20. 20 times 3, you are going to get 60. So you bring to the right side, you are going to have over here is 100 minus with 60. So next thing what I'm going to do here is I'm going to get t minus 6 equals to 100 minus 60. We are going to get 40 divided by 4. So I'm going to get 10. So t here I'm going to get plus 6. So t is going to be 16 seconds. T here is going to be 60 seconds. That's our value of t. So it means that over here t minus 6 is going to be 10 there lah. Okay, isn't it? Class, can? Did you get t? Can. Okay, t is going to be 16 seconds. Okay, next is going to be the average speed. Okay, you have already your distance just now. Okay, total distance is going to be, okay, so this one is A. So your B is going to be average speed. It's going to be total distance is 100 kilometer over total time is going to be 16 seconds. So 100, sorry. What did I miss out is here. Not straight away. Okay, so 100 meter. So I have to convert first. 100 meter. So from meter to kilometer. So I have to divide it by what?
1,000.
1,000. So how about 16 seconds? I'm going to convert into hour. going to divide by
Times 60.
60 times 60 is going to be 3,600. So means that I'm going to divide by 3,600. Am I right?
Yes.
Second to hour. Okay. So over here we are going to have, okay, wait, I'm going to calculate into my calculator. Easy. 100 over 1,000. Okay. Divided by 16 over 3,600. So I'm going to have over here 22 1 over 2, so it means that I'm going to get 22.5 kilometer per hour. Oops, what happened? Okay, sorry. Okay, I'm going to get this one per hour. Okay, you're going to get that one. Can, class. By using your calculator straight away, you can get that one. Isn't it? Can, class?
Can, teacher.
Can. Okay, finish for our discussion. This one about our 7.2b. Okay, we are going to the next one. Okay, our learning standard is going to be interpret speed time graph. Okay, speed time graph, and describe the movement based on the graph. You can open to your textbook page. This one, 200. Okay, 200. Okay, so for this one we are looking straight away to example 14, page 201. Okay, the speed time graph shows the motion of one cylinder car for a period of 15 seconds. Okay, calculate the rate of change of speed, this one in meter per second for the first 5 seconds. Okay, first 5 seconds. So you are going to look here. First 5 seconds means that around here. So change of speed means that for the initial and final over here. So means that 40 minus 20 divided for our 5 second over here, which is 5 minus with 0. Final speed minus with change of speed over here is going to be final speed minus with initial speed. Okay, final time is 5 minus with initial time is 0. That's why you are going to get 40 minus with 20 divided by 5. You are going to get 4 meter per second, negative 2 there. Okay. Okay, describe the motion of the car for the second 5 second. Oh, okay, this one. Okay, this is going to be this one. After 5 seconds over here, there's going to be our uniform speed. Okay, because this one we call as uniform speed. Why? Because this one is speed time graph. If we have distance time graph, okay, distance time graph is going to be our what we call stationary. That's the difference. Yeah, it's going to be uniform speed, that one. Okay, speed of 40 lah. This one you look at 40 over here, 40 meter per second for the period of 5 seconds. Yeah. Okay, calculate the total distance in meter traveled in the period of 15 seconds. So if the question asks for total distance, means that you are going to find the what? The area under the graph. For this one, area under graph is going to be for our trapezium over here, our rectangle over here, and our another trapezium over here. Okay, that's why that goes here, got 600 meter. That's for our example 14. Okay, next for example 15 over here, Mr. Daniel won't drive his car to convenience store to buy newspaper. The speed time graph shows the motion of the car from his house to the road junction before reaching his destination. Describe the motion of Mr. Daniel Wong's car for the first 10 seconds. Okay, so for the first 10 seconds over here, you are looking at 0 to 10 over here. You can say about rate of change of speed over here. Okay, this one is going to be accelerate, isn't it? Okay, so for this one, you are going to have the initial speed, the final speed is going to be 25 minus with initial speed is 0, divided by time over here 10 minus with 0. That's why you got 2.5 over here. So it's going to be accelerates. Accelerates is going to be positive. Answer that one. Okay. So the next one, what happened to the motion of car from 10 seconds till the 20th second is going to be is to be uniform speed over here. It's going to be uniform speed with 25 meter per second, that one. Okay, move at uniform speed of 25 meter per second for the 10 second till the 20th second there. Okay, calculate the distance travel and meter travel during deceleration. Okay, where is deceleration? Just now, I just mentioned to you, this called acceleration. So deceleration is going to be here, from 20 to 35 seconds over here. This is going to be deceleration. Deceleration. Okay, deceleration. This one is going to be acceleration. Okay. Okay, for deceleration over here, and describe the motion of the car for the period. Okay, first of all, the question here, calculate the distance. So under a graph. So this one is going to be our triangle over here. Okay, our triangle over here. So this one, wait. C dan, wait. C, oh sorry. Calculate the rate of change speed in meter for the last 5 seconds. Sorry, for the last 5 seconds. Okay, for the last 5 seconds, it's going to be, we don't have 5 seconds over here. So it's going to be the same with 20 to 35 seconds. This one, deceleration, is going to be deceleration. So we are going to find the rate of change of speed. So we are going to take the initial speed is going to be 25. Final speed is going to be, over here is 0. So 0 minus with 25. So over, you are going to get this one also, 35 minus with 20. So this one is going to be the same with our solution over here is going to be negative 5 over 3 meter per second, negative 2. Okay, it's called negative. Why? Because it is deceleration. Okay, why? If we take this one, 20 to 35 is it is 15 seconds. Okay, but the question asks for the 5 second. Why did we take 15 seconds? Because we didn't have the 15 second speed over there. So we know that they are in the same gradient. Okay, in the same gradient. So that means the rate of change is going to be the same. Okay. Okay, so for the distance travel here, that's we are going to find our what we call the area under graph. Okay, the area under the graph. Okay, we have over here 187.5. Okay, so the car travel for this one, you are going to make what we call a story, that one. Okay, for 187.5 meter in 15 seconds with a deceleration of 5 over 3 meter per second, negative 2. Okay, this one also, if you set deceleration, you are no need to put negative. This one, the answer can be written as acceleration equals to negative. Okay, so if it put deceleration, so it's going to be positive 5 over 3. Of course, this one, because this one already stated as a deceleration, so no need to put negative. If you put acceleration, so you have to put negative for the answer for C, that one. Okay, that's going to be our example 15. Is it okay with you for this one? Ken? This one in your textbook, page 201. Yeah, 201. Is it okay with you, class?
Yes, teacher.
Yes, can. Okay, no problem. Okay, so we are going to look. Yes, Dania. Thank you, Dania. Okay, now we are going to look into our what we call Nilam book. Okay, Nilam book, page 118. Please open to page 118 in our Nilam book over here. Okay, so we are going to look at number 5 over here. Okay, total distance traveled. This one given already. The total distance traveled by a motorcycle in the speed time graph is 186 kilometer. Okay, so the question here, number 1, find the acceleration in the first 6 hours. Means that over here. How did we want to find the speed? It's given already, isn't it? Okay, so find the acceleration there. How to find the acceleration? Remember? Okay, to find the acceleration, okay, means that we are going to have final speed minus with initial speed, okay, and double E, over final time minus with initial time. Okay, for this one you have to determine. Okay, so oh yeah, Norazika, page 118. Oh, got somebody asking. I didn't look at the chatting there. Okay, so for this one, this is gonna be your final speed. This is gonna be your initial speed and initial time. Okay, this is going to be okay. So you are going to have final speed over here is 10 minus with initial speed is 0 over your final time here is 6 minus with 0. So over here actually you have 10 over 6. So 10 over 6 you are going to get 10 over 6 you're going to get 1.67. Okay, this is going to be 1.67. And how about the unit over here? You already have our kilometer per hour. This one over hour, so you are going to have kilometer per hour negative 2 there. Can class? Is it clear?
Yes.
Yes, okay. For number 2, okay, we look at number 2 over here. Describe the motion of the motorcycle for the period of 6 seconds, okay, 6 seconds over here until 12 seconds. What is the motion of the motorcycle? We can say it's going to be what? It's going to be what? Uniform speed. Okay, for number 2 over here, it's going to be uniform speed. Okay, uniform speed with speed what? 10 kilo. Uniform speed 10 kilometer per hour. You are looking at here straight away. 10 kilometer per hour. Okay, for number 2. Okay, for number 3 over here, find the value of V. How we want to find the value of V? How? By looking at our distance here given already. Total distance given already. So we know that the area under a graph is going to be our distance. So for this one, I'm going to find one by one lah. Okay, I'm going to find one by one. Okay, this one straight away lah. I think I can have this one as my for my trapezium. This one, this is the shape for trapezium straight away. And the second one also I have my trapezium. This one for our trapezium. This one. Okay, so means that I'm going to find my area under graph. Okay, so area under graph for the first one over here is going to be 1 over 2 times with the parallel line is going to be 12 and 10 there. Okay, so it's hours, so no need to convert. Okay, so it's going to be 12 plus 10 and 12 and 10. Sorry, 12 plus with sorry, not 10. It's going to be what? 12 minus 6, isn't it? It's going to be plus 6 over here. Okay, times with our height there is going to be 10. Okay, that's going to be our trapezium for the first one, that one. And plus with our another trapezium, which is we have over here is 1 over 2 times with our parallel line here is going to be 10 and V. Okay, 10 and V there. Okay, times with our height over here is 18 minus with 12, you are going to get 6. Right? Okay, so now I'm going to simplify first. So 2 and 10. Okay, 2 and 6. This one 3. This one is going to be 5. So I'm going, okay, this one, sorry. Forgot. Equals to 186 kilometer. Okay, so what we have over here, I'm going to solve that one first. 12 plus 6 is going to be 18. 18 times with 5, I'm going to get 90. So the whole thing here, I got 90. I'm going to bring to the right side over there. It's going to be minus. So for this one, I'm going to write back 10 plus V, okay, times with 3 is going to equals to 186 minus with 90. Okay? Okay, how I get 90? From here. This one is totally 90. Everything there. Okay, so 186 minus with 90, I'm going to get 96. So, this one I'm going to get 10. Oh, not times lah. 10 plus V. Sorry. 10 plus V is going to be 96. Now, I'm going to bring my times 3 over here to the right side. It's going to be what? Divide by 3 over here. So 96 divided by 3, I'm going to get 32. Okay, so over here, V is going to be 32. Now I'm going to bring what? I'm going to bring 10 over here to the right side. So 32 just now is going to be minus with 10. So my V here is going to be 32 minus 10 is going to be 22. That's our V here is speed. So kilometer per hour. That's going to be our V. Can class? Can. Thank you, Fatin. Okay, thank you. Okay, next. We move to B here. Okay, the total distance, this one also given the total distance travel by a car in the speed time graph is 5 to 6.5 kilometer. Okay, describe the motion of a car in the last 1.5 hours. Okay, last 1.5 hours is going to be where? Between 4.5 and 6, isn't it? So it's going to be deceleration. So if you are going to find the deceleration over here, you are going to find the change of speed, right? Okay, change of rate of speed over here. So I'm going to get, okay, this is going to be our initial. This is going to be our final speed. Okay, so means that final speed is going to be 0 minus with our initial speed is 117 over, so that one 6 minus with 4.5, 6 minus with 4.5, actually you are going to get, sorry, you are going to get 1.5 lah actually. Okay, last 1.5 hours, isn't it? So this one you are going to get negative 117 divided 1.5, you are going to get negative 78 kilometer per hour. Okay, so if I'm going to describe, so here we have our rate of change of speed is negative. What does it mean? If you want to describe as deceleration, so you are going to take that the car, okay, decelerates at 78. No need to put negative because you already mentioned decelerates over here. The car decelerates at 78 kilometer per hour. Okay, for the last 1.5 hours. Okay, that's you are going to describe the motion of the car. Okay. Okay, next for number 2, find the value of t. Where is our t? There. So we are going to find the total area under a graph is going to be equals to our distance already given here, 5 to 6.5 there. So what we have over here, straight away I think I'm not going to take straight away my trapezium. Why? Because our T is the first one there. So I'm going to take this one as my triangle. The second one, I'm going to take my trapezium, this one. The second one, I'm going to take the trapezium there. So means that what we have over here for number 2 here. Okay. I'm going to take the first one is going to be 1 over 2 times with base there is going to be t times with height there is 117 plus with, okay, plus with our trapezium over here, okay, is 1 over 2 times with our parallel line here is going to be 4.5 minus with t, the first one there, okay, 4.5 minus t, and then the other one is going to be plus with 6 minus with t. Okay, this is going to be our parallel line, okay, times with the height over here is 117. Okay, the total here is going to be equals to 5 to 6.5. Wow. Can class? Okay, so what we have
Can,
over here,
teacher.
okay, what we have over here, I'm going to solve this one first. Okay, 117 divided by 2 first, I'm going to get 58.5. Okay, this one I'm going to get 58.5t. Okay, the second one over here, okay, this one, to solve this one, so 4.5, so I'm solve up here 4.5 minus t plus 6 minus t, so we are going to have 4.5 plus with 6, we are going to get 10.5 minus with 2t, right? Okay, inside there, so 2 and 11, 117, this one I can simplify, I get 58.5 times with 10.5 minus 2t inside there, this one plus, equals to our 5 to 6.5. So this one I think I'm gonna make it okay, times inside first, this one, okay, times this one, okay, because why? Because I'm going to solve with 558.5 there. So what we have over here, okay, is gonna be a lot of 58.5 times with 10.5 over there, I'm going to get 58.5 times with 10.5, I'm going to get 614, okay, 58.5t plus with 614.25, okay, minus with, okay, 58.5 times with 2 117, 117 again, okay, so this one is going to be equal to 5 to 6.5, so means that this one, this is going to be t, so this is like terms, this one I'm going to bring to the right, so it means that what we have over here, 58.5 minus with 117, I'm going to get negative 58.5t is going to be equals to 5 to 6.5 minus with 614.25, I'm going to get 87.75 minus, so it means that over here I'm going to get t is going to be negative 87.75 divided by negative 58.5. So divided by 58.5, I'm going to get t is going to be equals to 1.5 hour. 1.5 hour. Can class? A lot of work. Can class?
Can, teacher.
Okay, so that's how you find your t there. Okay, that's it. Okay, finish our page 118 over here for number 5. Okay, so it's gonna be your self practice over here. So we have 3 of our self practice over here. Can we do all 3? Diam tanda setuju ya. If none of you have an objection, so I'm gonna proceed with 1, 2, 3, can?
No.
At last, Diana bersuara dah. Okay, so we go for 1 A B and 3 A B C. Can? Can. Okay, so this one is going to be our 13th of July. This one. Okay, so next one. Okay, gonna proceed with our last one. Our time until 12. This one. Today we have 3 period already. 3 period, isn't it? Am I right? Correct me if I'm
Yes.
wrong. Correct me if I'm wrong. 3 period, Fatin. Yes. So means that we're gonna stop 12:30. Okay. So we have another 22 more minutes. So I think I'm gonna finish the chapter 7 today. By today. Okay. So for our last learning standard here, solve problems involving speed time graph. Okay, you can look at example 16 over here in page 203. Okay, this is going to be our last subtopic for our chapter 7 already. Okay, so the speed time graph shows the motion of a car for a period of 14 seconds. Calculate the average speed in meter per second for the first 6 seconds. So it's going to be here. First 6 seconds. It's going to be this one. Okay. So the average speed is going to be the total what? Total distance, isn't it? Is there any total distance given there? None. So how? So how? How we are going to find the total distance there? So did we have our speed there is going to be means that we are going to find what? Area under a graph. Am I right? Area under a graph for this one only. For this one only. Okay. Okay. For that one only, you are going to find the area under a graph for your what we call for that one. Okay, so for A over here, if you look over here, total distance you are going it's given over here is 50 meter. How do you get 50 meter? Is this one by 2 over here, which is a trapezium and also a rectangle over there. Okay, so this one average speed, so for this one 50 meter, so means that for average speed is total distance is 50 meter divided by total time is 6. So the answer is going to be 25/3 meter per second. That's going to be our A. Okay, for our B here, the value of T. The value of T, if the distance traveled by the car for the first 4 seconds, is half the distance traveled at a uniform. Okay, means that is already given over here. For the first 4 seconds over here is half the distance traveled at the uniform speed over here. So what can you say over here? You can say that you are going to make a equation. Okay, this one, the equation given over here, different distance for the first 4 seconds is going to be half of distance traveled at a uniform speed. So you can make your equation over here, which is this is going to be two type of you have over here. Total distance over here is going to be, the first one is your trapezium, and the other one is going to be your what? Your rectangle over here, uniform speed over here. It's going to be area of trapezium is going to be area of half of area of rectangle. So you are going to have your T over there. Okay, T equals to 10. Okay, the value of V if the acceleration for the last 2 seconds. Okay, this one, the T that I just now is 10. Okay, T here is 10. Already we have 10 seconds. So here the value of V if the acceleration for the last 2 seconds is 3.5 meter per second negative 2. Okay, so means that over here we didn't have last 2 seconds. So what we have over here, we can take our final here is going to be our speed here is v. Okay, if the acceleration here means that the rate of change of speed over here is going to be the initial speed, which is our v. The final speed is going to be our v. The initial speed is going to be 10 over here, initial. Okay, and we are going to take our time over here. Final time is 14 minus with our initial time here is 10, because we didn't have our the question over here asking for last 2 seconds. We didn't have, so we know that it's going to be the same gradient over here. If I take this one, 2 seconds minus 2 is going to be 12 seconds over here. So it means that 12 seconds over here is going to be on the same gradient over here. So we can take our rate of change or speed for that one. So we can find our v here, okay, the final speed. So you are going to replace here, v minus 10 over 14 minus 10 is going to equal to 3.5. So you are going to take your v here is 24 meter per second. This is going to be your speed actually. Okay, this is for your example 16. And the last one over here, last one, oh no, second last, sorry. Okay, next is going to be example 17 in your page 204. Okay, example 17. The speed time graph shows the motion of two vehicles over here. We have a graph OAB, the pink one there, represent the motion of Encik Zabadi's car. And graph CD, okay, the green one, that one is a motion of taxi driven by Mr. Low. The difference between the distance traveled by the car and the taxi in the period of 24 seconds is 160 meters. Okay, this one given already, the distance traveled. Okay, distance traveled by both of the car means that the area under graph. Okay, the area under graph, the what we call the difference there. Okay, calculate the value of v. So we are going to find what? The distance traveled by each of the vehicle there. So the first one, we have a trapezium. Okay, that's why OAB over here, 1 over 2 times with v minus 10. Okay, times with 24 plus with 16 over there. Okay, 24 plus with 16. How get 16? 24 over here minus with 8 there. Okay, we got 16 there. Okay, that one for the parallel line AB there is going to be 16. Okay, minus with, okay, the distance traveled by the taxi driver is CD there is going to be our triangle. So it's going to be 24 minus 8 is going to be 16 originally. Okay, so 1 over 2 times 16 times with V there. So you are going to do your expand there. So you are going to have your V equals to 30. Okay, how did get 160 here? Because of our difference between the car and the taxi is going to be 160. That's why we have V is going to be equal to 30. So if you replace back our V there, it's 30. You are going to get 400 minus with 240. You are going to get back your 160 meter. That's for example 17. Okay, the last one over here. Okay, the speed time graph shows the motion of van for a period of t second. Calculate the rate of change of speed in meter per second -2 for the first 3 seconds. So it means that we are going to find for our initial final speed 30 minus with initial speed divided by our time over here 3 minus 0. So you are going to get 6 meter per second there. Okay, the distance in meter traveled for the first 10 seconds. So it means that you are going to find the area under the graph over here. This is going to be your trapezium actually. Okay, now or this one it's separate, the trapezium over here and the rectangle there. So it's going to be 273. Okay, the value of t if the magnitude of the rate of change of speed after 10 seconds is the same as the magnitude of the rate of change of speed for the first 3 seconds. So what does it mean? It means the acceleration over here. Means that the acceleration you have just now is 6 meter per second -2 over here. is going to be the same with this one, deceleration. Okay, so it's going to be the same over here. So what we have over here, we know already this one is the initial final speed is going to be at 0, minus with the initial speed here is 30, minus with t minus with 10, t minus with 10 over here for the our last what after 10 second over here is going to equals with actually straight away you have 6 meter per second negative 2 already, you have that one, but it put here again it's going to equals. Okay, so you are going to do some equation over here. Okay, this one, if you look over here, the rate of change of speed is in the same direction, so means that it's going to be acceleration over here. This one said acceleration, means that this one, if you look over here, it is a deceleration. That's why it put over here is negative in front of it. Okay, so we have already 30 over t minus 10, and then you put here, you are going to have t equals to 15. Okay, t equals to 15 means here is going to be 15 second. Okay, it's going to be like an equation over there. Okay, so this is going to be your last one, example 18. And for our last one in our Nilam book, before we stop at 12:30, right? Now it's 12:20 already. Another 10 more minutes for me to finish up my discussion. Okay, we have A and B here. Okay, we move one by one. Okay, so the diagram 1 shows a graph of the speed time graph of a car within t hours. Okay, sorry, page 119. Page 119. Nilam book, page 119. Just now 118, isn't it? Okay, so state the length of time in hours when the car was moving at uniform speed. The length of time. Already, this one is uniform speed, isn't it? So, you are going to minus only 7.5. Minus with 4, you are going to get 3.5 hours. Can? Okay, because it say about uniform speed. Okay, uniform speed. So that's going to be uniform speed. Okay, next. Calculate the rate of change of speed in km per hour, -2, of the car in the first 4 hours. So the rate of change of speed, remember you are looking at the final speed, 80, minus with initial speed, 50, divided by 4 minus with 0 lah. That one, for our first 4 hours. For 80 minus with 50, you are going to get 30. 30 divided by 4, you are going to get 7.5 kilometer per hour. -2. That's going to be your number 2. Can? Class?
Can, teacher.
Okay, thank you. Next, number 3. Okay, for number 3 over here, calculate the value of t in hours if the whole journey of the car is 600 kilometer. Means that you are going to find our area under a graph for this one, right? So the first one you have over here, this is going to be your trapezium. This is going to be your rectangle, and the third one is going to be your triangle. I'm going to find one by one like one. Okay, so what I have over there is, the first one is a trapezium, so I'm going to have over there is 1/2 times with the parallel line is going to be 50 plus with 80. Okay, times with our height there is going to be 4 plus, okay, next our rectangle there is going to be 7.5 minus 4 is going to be 3.5, times with our height there is going to be 80. Okay, plus with our triangle there is going to be 1/2 times with t minus with 7.5 for our base there, and our height here is going to be the same with 80. Okay, so it's going to be equals to 600 kilometer. So we're gonna find one by one here. So 2 and 4, 2. Is there anything? Okay, 2 and 80, I get 40. Is there anything? None. So 50 plus 80, 130 times 2. So I'm going to get over here 260 plus 3.5 times with 80. I'm going to get 280 plus, okay, this one I'm going to put like that only. Okay, I'm not going to expand. T minus 7.5 times 40. Just take like that. It's equals to 600. So what we're going to do next is we are going to move these two first. Bring to the right, and then I'm going to divide by 40. Okay, means I'm going to have over here t minus 7.5 is going to be 600. Okay, this one is going to be 260 plus 280 is going to be equals to 540 divided by 40. So 600 minus with 540 divided by 40, I'm going to get 1.5 over here, and then plus with 7.5, so I'm going to get my t here is 9. 9 what? 9 hours. That's going to be my t. Okay, class. Is it clear for our number 3?
Yes, teacher.
Yes, loud and clear, right? Okay, the last one. Now it's 12:24. Okay, another 6 more minutes. Okay. Okay, the diagram shows the speed time graph for the motion of an object. Okay, the object move from 0 to r. Okay, for a period of t second. Okay, so state uniform speed. Where is the uniform speed? There. 15, right? There. Here is our uniform speed. So it's going to be 15 meter per second. Calculate the rate of change speed of the object from O to P. O to O, okay, from here. O to P here. So for the second one over here, I'm going to get final speed is going to be 15 minus 0 over 20 minus with 0. So 15 over 20, right? 15 over 20, so I'm going to get 3 over 4. 3 over 4, or I'm going to get 0.75 meter per second negative 2. That the rate of change of speed or our acceleration, because it's positive, right? Okay. Okay, next, the number 3 over here. Calculate the value of t if the distance traveled in the first 20 seconds is half. This one you have to do. Okay, distance travel. Okay, number 3. If the distance traveled in the first 20 seconds is half of the distance traveled from the 14 second to the t second. Okay, so means that half of it. So I'm going to find this is going to be our 20 second. So it's going to be our triangle there. If the distance traveled in the first 20 seconds is half of the distance traveled from the, so means that, okay, this one is going to be, I'm going to find the area under graph first. So this one is going to be 1 over 2 times with 20 times with 15 is going to be equals to 14 second to the 10 second. Okay, it's going to be here. It's going to be 14 to 30. It's going to be our trapezium over there. So it's going to be half. Means that is going to be, this one is half. So means this is going to be half from our trapezium over here. So trapezium over here is going to be for trapezium, for our 1 over 2 times with our parallel lines here is going to be 15 plus with 25 times with our base there is going to be t minus 40. T minus 40. That's going to be right. Okay, so what should I do here is I'm going to, so 10, 150 Okay, this one can I can 15 plus 25, I'm going to get 40, so this one is going to be 20. This one also 1 over 2 and 20. Straight away I can have 10 over here. That's all. Okay, so I'm going to get 10 times with t minus 40. So I'm going to bring 10 to that, so 140 and 150 divided by 10 plus with 40 is equals to t. So this one is going to be 15 plus 40, so I'm going to get 55. T is going to be 55 seconds. Right? Okay, class?
Okay, teacher.
Okay. Okay, another 2 more minutes. That means I'm gonna throw you with our self-practice 7.2D. Okay, this one also we are going to do just same like now. Number 1, A, B. Number 3, A, B. This is going to be your uh, homework. Okay, self-practice 7.2C, number 1 and 3. 7.2D also number 1 and number 3. Okay, so we stop until here. 12:29 already. Wait, I'm gonna stop our